In this video, I introduce a context distillation for large language model learning. Performance of large language models strongly relies on context tokens such as prompts. Large language models perform better when prompted with informative instructions and acquire new reasoning capabilities by generating a scratch pad before predicting final answers. Contingent on instructions plus text input to predict the scratchpad plus the final answer. Large language models are fine-tuned to predict the final answer conditioned on the task input without seeing the instruction or using the scratchpad. Context distillation is the fine-tuning method to train large language models to internalize the step-by-step reasoning capacity. Namely, the step-by-step reasoning is distillated in large language model parameters, as shown here. This teacher model and this student model that use minimal instruction plus raw text input to predict the final answer. In the classical knowledge distillation method, the teacher model say the teacher generates a label Y for a given input X, and the student model say the student mimics the teacher by predicting Y conditioned on X. Starting with theta teacher not equal to theta student, the distillation process is driven by difference between their parameters. In contrast, starting with the theta teacher equal to theta student, the context distillation process is driven by difference in the input X and the prediction Y that the teacher and the student see and predict. Context distillation framework consists of four components, namely a raw text input distribution D, a teacher template T teacher, a student template T student, and an answer extract F as showing here, this F function. Context distillation training fosters samples task X from D, and the large language model generates a completion Y conditioned on a T teacher X that maps X into a large language model prompt. The large language model is fine-tuned to predict F conditioned on T student X. During distillation process, the teacher model theta teacher is fixed. The probability distribution of the completion condition on the prompt is defined as P theta, and the optimization objective L is defined as expectation over the input distribution D as shown here, which depend on D, T student, T teacher, theta student, and theta teacher. The mapping F extracts the final answer from the four teachers generation. For example, the function F strips away the intermediate reasoning process, and the student internalize the step-by-step reasoning process to directly predict what the teacher predicts at the end. For more details, please check with these references. Thank you.